crack on with it. So, review class, we on the Monday looked at the Unit 1 and 2 style derivative stuff, mainly on the applications of derivative, doing your max and min type stuff. So if we have any Unit 1 and 2 students, we could definitely have a look at that. However, the other class, we also were continuing on with our extended response of probability. So, given that we're all focused on that, let's start here. Starting at question 3. A train is declared to be on time if it arrives at its destination within 5 minutes either side of the advertised arrival time, which seems a bit insane. If anyone takes trains on a regular basis, they're usually on time pretty much exactly. So 5 minutes either side seems a bit, but whatever. The time difference between the actual arrival time and the scheduled arrival time, capital T, is the normally distributed random variable. So it is the time difference between when it should have been there, when it was scheduled, versus when it actually arrived. Positive T would mean later than normal, and negative T would mean earlier than normal. This is where it gets a bit confusing. Which way does it actually go? Normally distributed mean of 3 minutes. Time difference between actual and scheduled. So it would be actual minus scheduled. So positive would be later and negative would be earlier. Sorry, did I say that? I said the same thing twice, didn't I? Actual would be positive would be later, negative would be earlier. So, with that in mind, calculate the probability, correct to some number of decimal places. On any given day, the train arrives on time. So, we have our normal distribution, mean of 3 minutes, standard deviation of 3 minutes. That gives us most of what we need for calculating this. Normal CDF is going to be what we're going to be required here. Might as well go ahead and plug in the mean of 3 minutes, standard deviation of 3 minutes. And then from here all we need is our boundaries. So if capital T is the time difference, and on time just means it's between plus minus 5 minutes, what are we going to set for our upper and lower?
-5 and +5.
Yeah, it came in a bit low volume there, but
Yeah.
I think I heard plus minus 5, yeah?
Yeah.
Yeah, that'll be it. 5 and 5. And yeah, a 74% chance of being on time. Dear God. That would be terrible. But anyway, that's what we've got. On any given day, the train arrives late. There's 2 ways we could handle this. What might we do?
Would it be 0 to... Oh, sorry, -5 to negative infinity.
Mm-hmm. Yeah, so we could do that. Negative infinity to -5, and then double that is, I think I heard at the end there, doubling. Because that would give you the one side of it. And then, why does that seem off? Negative infinity, -5, 3, 3. What happened there? Because it should just be 1 minus this. If that's the probability of being on time, the probability of being late should be 1 minus on time. What did I do differently there? Because late should be on the outside of that. That seems very strange. What happened there? Normal CDF. The mean is 3, the standard deviation is 3. Oh yeah, you had a question?
I don't think I understood why we did it from negative infinity to -5.
Yeah, because basically what was going on there was to say, if it was on time, it was between plus minus 5 minutes, and so to get late, it just has to be outside of that boundary. So if I draw up a normal distribution,
So shouldn't it be like on both sides? Shouldn't we
yeah,
calculate it on both sides?
yeah, you could do it both sides, but doubling should also do the same thing.
Yeah.
Wait, does this make sense if it says with a mean of 3 - 5, you can't get -2 minutes? Or
You can get negative because it just means it arrives early. Because it's plus, so any negative number is an early arrival.
but it says that the time distance between the actual arrival time and oh, okay, no, understood.
Yeah, because you're doing actual minus scheduled.
Yeah.
Unless they did mean the modulus of that, like stripping the negative off, but that doesn't really make too much sense for setting up the normal distribution, because what you would need to have would be mean sitting there at 3, and it doesn't make sense for numbers to go up on both sides. So it should eventually go negative. But anyway, to get the diagram of like why the numbers were what they were, it was within 5 minutes either side of the advertised arrival time. So does that, the mean is 3 minutes either side of the arrival time. Within 5 minutes, yeah, Nihal?
We're doing A two, right?
Say again.
We're doing the second part of A, right?
Yes,
Yeah,
but I
so
think we
it
might need
says
to update I as well.
I.
Yeah, so the
Um,
first part I
um,
think also might need an update because looking at it now, if it arrives at its destination plus minus 5 minutes either side of the advertised arrival time, the mean is 3 minutes, and so no, it should still be plus minus 5.
okay, so what I was going to say is
Yep.
that I'm confused about why we did negative infinity to -5. Shouldn't
Mm-hmm.
it be 5 to, so that still gives the same thing.
Oh, yes. Okay. No,
And
we've
it's
done it
just the
right.
same
I've
as
just
You
like,
don't
okay.
double it
It's
because
not
it's late,
symmetrical.
because it's not late.
Yeah. Yeah.
Yeah.
That's the issue. This isn't a zero. So -5 to negative infinity should be a stupidly small number. This now should be a lot more. Yeah, okay. Doubling it was the stupid thing. Should have instead gone with now 5 to infinity to get both sides and then just adding the 2 together. And now that should be the same as if we had done 1 minus this. Okay, good. So just because it's plus minus 5 does not necessarily mean the center was 0. They were separated in a different number of standard deviations from them. Fun. See? Normal distribution, man. Maybe it's just my weakness. But it definitely seems like some of the harder questions of this. But yeah, so those are the two main ways of going about it. Either doing another normal CDF, I guess another two of them, and adding them up together, or because you know what is on time, you could also get late by just doing 1 minus on time.
Oh, I just noticed we wrote -5
A
instead of -2. We
negative.
wrote -5 instead of -2. The very like first normal CDF we did because it should have been what's it called 3 - 5 instead of 0 - 5.
Three.
Or
Hang on, how do you... The first normal
so
CDF we did was between plus minus 5.
was it not the mean +5 and the mean -5?
No, because the thing on the x-axis is arrival, is difference of arrival time.
Okay.
Yeah, so a mean of 3 just means it's normally 3 minutes late.
Oh, okay.
Yeah, that's all that is. Because that's what I thought might have happened. I was like, shit, or maybe it's like +5 onto the 3 and -5 onto the 3. But no, this ends up being that ended up being fine. It was more so just me forgetting that it wasn't symmetrical just because it was +/5. But yeah, cool. Tough one to start with. Okay, next up. Train company needs to pay a fine if they are consistently late, which they basically are, but whatever. If the train is late less than twice in a 7-day week, they are not penalised. But if they are, they're fined 3,000, and if they are late more than twice, they're fined 10,000. Nice. Construct a probability distribution table for F, which represents the probability of them being fined any given number of dollars. Okay. So probability distribution tables, as a reminder, you have the probabilities on the bottom and you have the outcomes on the top. Probabilities we'll have to calculate ourselves. Outcomes we'll have to determine based on what's presented in the question. So if we think about the outcomes of this scenario, they are either getting fined or they're not getting fined, and if they are being fined, they're being fined different amounts depending on certain conditions. So the 3 outcomes in this situation are going to be what? Any suggestions? It's all about how much they're going to be fined on any given scenario. So with that in mind, they're either not fined at all, not penalised, in which case you have outcome of $0. They could be fined 3,000 or they could be fined 10,000. So 3k, 10k. Those are the only outcomes, unless I've missed one by reading it incorrectly. Now we've got to find the probabilities of each of these things occurring. So, to not get fined at all, the train needs to be late less than twice. So, it can be late once, it can be late 0 times in a 7-day week. Something about the way we're going to calculate this probability has changed based on the wording of this question.
Is this binomial?
This is binomial. Yeah, what gives you that idea?
Less than the amount of times.
Less than the amount of times. That's more or less just an inequality. So that'd be like x less than 2, which you could do in normal distribution or continuous as well.
It can be late or it cannot be late. Sorry, that's what I'm going to say.
Yeah, there you go. Late or not late, perfect. And you've got a number of trials as well that you can use, which is your 7-day week. Awesome. Those are the 2 main things to watch out for. So let's go ahead and do exactly that. Binomial PDF for this, CDF, because we're doing a range of outcomes. 7 trials, probability of success. We're just going to put a dummy variable in there just to fill that in later, so I can copy paste our already calculated probability. And then for this one, it was lower bound of 0, upper bound of 1, because it was less than 2, not less than or including twice. All we're going to do from there, so this was about how many times it was late, so we need the probability of late, which is this one here. So I'll grab a copy of that, and I might even just define that as P. P equals that. Now when I plug it in here, we're going to get the actual result that we were looking for. And that gives us the likelihood of being not fined at all, which makes sense considering what we were looking at. It's normally 3 minutes late, and it only has a very small tolerance before it's considered truly late. Cool. Just going to double check. Yep, we had n was 7. Probability of being late was that. It's pretty likely. And then to get specifically late on less than twice, yeah, 0 to 1. Awesome. And then we would just fill that in on our probability table. Does it tell us anything to do with... No, nothing to do with decimal places. So to make life simple, I'll just go until it feels right. I don't know, 0015. Now, for the $3,000 outcome, if they are late exactly twice in a week, they are fined $3,000. How do we do exactly twice in the CAS?
PDF?
PDF, yeah. 955A, number of trials, probability of success. Should be able to just do that there. Yep, sure can. Okay, 0.013. And the big one, the $10,000 fine, late more than twice. Just going to go ahead and basically grab a copy of this. Lower bound would now be 3 because it's got to be more than twice. Upper bound is going to be, well, the total number of possible. Jesus, 98%. This is less than 1%. This is basically just 1%. So 98% to total everything up makes a decent amount of sense. 0.98. Technically it goes up to 99 through rounding, but I think we'll just leave it as 98 just so we can... Anyway, that gets us our probability distribution table. Any questions there? Otherwise we move on. Use the table to calculate the expected value and standard deviation of capital F. So we're doing discrete here. We know it's discrete because, well, it came from binomial, so it kind of has to be discrete. But we've also got a probability distribution table, and these are very, very often just discrete. So, can anyone remind me how we do mean or expected value for discrete?
Find the sum of the x value multiplied by the probability.
Yep. You just multiply downwards, and then you just add each of the individual results at the end. Fairly trivial. Do exactly that. So the 0, 1 you can basically just ignore. The only ones left is going to be 3,000 times this probability plus 10,000 times this probability. Sure enough, it's pretty close to 10,000. From there, standard deviation, a little bit different. How do we do standard deviation for these? So it's always going to be the square root of variance, specifically e of x squared minus e of x all squared. So we already have e of x, so squaring this gets us the latter half. All we need to do from this point onwards is calculate our e of x squared. So let's just assume we've squared this and just chucked it in. Awesome. E of x squared. What does that mean in the context of discrete?
For the x values.
Squaring the x values and then the exact same procedure. Correct. So we just grab our old value, spam click left. If you do it fast enough, you can actually get the cursor to move a little bit more afterwards. That's going to get us, of course, a nasty number, but probably not as nasty as just squaring this. Okay, so it's e of x squared, which is, that was this one, yeah? minus e of x all squared, which is that one, and then square rooting the whole thing. Standard deviation 879. Standard deviation 879. Cool, all sorted. The operators of the station continuously monitor the proportion of trains which arrive at the station which are classified as late. Of the 268 trains which arrive on a particular day, 33 were late. Find a 95% confidence interval for the proportion of trains which are late. There's a few things in there that we need to be cautious of. What area of probability are we actually using here?
Proportional.
Yeah, that's it. That keyword proportion is carrying a lot of weight. Because if that's not there, you might start doing this like binomially, possibly. Because it definitely has that sort of vibe to it. Still just late or not late, and you've got a number of trials, and you can absolutely do a confidence interval for binomial. But that keyword proportion makes all the difference, because now your confidence interval is in terms of is fractional rather than integer. So that's good to know. All we need to do from here is remember, how do we do a 95% confidence interval? Given that this is tech active as well, we have a specific CAS function for this. We just got to know how to use it properly. Anyone remember where it is specifically? It's alright. It's under the statistics menu, confidence intervals, and then you want option 5, 1 prop z interval. That's the one that will automatically calculate our confidence intervals. Sea level is already provided as 0.95, that will be 95% confidence interval. It's looking for an x and an n. What do we think is going in those spots?
Is it 33 for x and 268 for the n?
Absolutely. 268, number of trains, 33 were late. That's 33 quote successes in the context of our confidence interval. Hit enter, it's going to give you nasty fractions. Don't worry, you can control enter that all the way down. It said 3 decimal places, so 0.0838 and 0.162. C lower and C upper are the things you care about, and it also gives you your p hat as well. So let's say, for instance, instead of them saying 268 and 33, they might have said p hat was 0.123 or something to that effect. You would have to then go out of your way to figure out how to flip that, or how to split that between x and n. You pretty much will always be given either x and n directly, or n and the p hat value, because it's not quite good enough to just do whatever the simplified fraction is, because n does actually have a pretty large impact on the width of your interval. But anyway, that's exactly how we do it. Easy. So again, for everyone else that might have missed it, statistics menu, confidence intervals, 1 prop z interval. 2 prop, I guess it's just doing 2 of them. You got 2 separate spots for x's and n's. You only really want the 1. By the way, if you make a mistake or anything, you can actually edit this directly. So you can see you've got your xn and 0.95. You don't have to go all the way through the menuing again and plug in everything identically if you did make a mistake, or maybe you need to calculate another confidence interval and compare them. You can just edit directly in there. Anyway, difference between the scheduled arrival time and the actual arrival time is now given by a new function. Find, correct to 1 decimal place, the expected value of d, where d is given by the f of d function. What are we going to do here?
solve an integral
Mhm.
pi from pi to 3 pi equals 1. Solve for d.
So d is the is like the x in this case. The
Oh
procedure
yeah,
you're thinking of is like, yeah, where you solve an additional coefficient.
yeah.
A little bit different. This one says find the expected value.
Then times it by x at the front.
Yeah, exactly. You're just going to slap an x at the front, or if you're being faithful to the variables, it would be d times f of d. But okay, so 1 plus sine of just x on 2. And that's the full function. Awesome. And yeah, this will also be on your formula sheet as well. So since the domain was pi to 3 pi, we're going to exactly do pi to 3 pi. And as per formula sheet or our memory, it's always just x times f of x. Whatever comes out is the expected value. We wanted one decimal place, so we're just going to go ahead and do 5.0 for our final answer on that one. Cool. Part F, final one of this section, and it looks like an easy one to finish up unless I'm misreading it. Find the probability that one of these trains will arrive more than 8 minutes after the scheduled arrival time.
Would it be an integral from 8 to 3 pi?
Sounds pretty good to me. 8 to 3 pi of just the function. Whatever comes out of that. 1%, not roughly 2%. What are we doing here? 4 decimal places. So yeah, obviously just round that to 4. Yeah, so this is find a probability, and when it comes to continuous probability, that's always about integrals. Finding a probability over a certain domain, more than 8 minutes up until 3 pi. Kind of funny that they're using pi for part of the domain, considering its scheduled arrival times. So, actually, how far does 3 pi get us? How late can this train be? 9.4. It's a bit better. Anyway, yeah, that's the full sequence there. Usually they have something a bit crazier at the end, but that one, in this case, the more crazier stuff was on the interpretation of, what's on our x-axis. It's what I sort of mean by the normal distribution being the tougher ones. But yeah, that's the full sequence there. I've noticed that the class has filled out a bit more, so if anyone wants to go through any of the differentiation stuff, we had a look in class 1 focusing on how to find max and mins, which is basically the main application of differentiation. We can definitely focus on some of those questions, should anyone wish, because I know both Unit 3, 4 and Unit 1 and 2 SACs are pretty much happening at the same time. And so if you guys need practice on this as well, just let me know. I'm more than happy to spend some time on that. This is supposed to be a review class of both at the end of the day. If not, we'll just crack on. Okay. Factory has 2 machines, machine A, machine B. Time taken to produce a widget is, well, for machine A specifically, is going to be given by this function. Calculate the value of k. This one we've talked about already how to do. How we're going to get this coefficient.
Excuse me. I don't understand why there is in the function f of x why there's a 0.
Yeah, so as a piecewise, they tend to do this. It's really unnecessary because it feels like every f of x, well, they didn't do it here, but a lot of the time in continuous they say, hey, here's the function and then it's 0 is everywhere else. Piecewise just means, you go left to right, function over this domain. Y equals 0 is also a function. It just basically is saying that this function has no value outside of the domain. It's completely redundant information. It's perfectly... They could have just did exactly this and left it at that. It's... I don't really know why they insist on putting that there, but they do.
Yep, okay.
Anyway, find the value of k. We said it before. How are we going to do this one?
Go for integral equals 1.
Yeah, exactly. Force the integral to be equal to 1. Perfect. Let me just get it copied down. Minus x all squared. Yeah, so the whole premise behind that is the area under a curve of a probability density function should always be equal to 1. And so if you've got other coefficients in there that are unknown, then forcing your integral to be equal to 1 over the full domain. Yeah, okay. Let's do the k instead. Forcing that to be equal to 1 will therefore force your coefficient. Perfect. Okay, is it okay? 17c, unit 1 and 2? Yeah, we can absolutely pivot onto that. 17c, unit 1 and 2. Okay, where are we at now? We're in the 18s. We're only a little bit of the way into this one, so we'll come back to this after we have a crack at some of the differentiation stuff. 17c. What's going on here? Differentiating xn where n is a negative integer. Cool. Okay. They've done a bit of first principles stuff. Was there any parts of these in particular that you were struggling with, or was it more just like the whole bit to do a bit of a refresher on? Whole bit? Sure. So what's essentially going on here is they're saying, hey, you don't explicitly have a spot on your derivatives formula sheet to solve these particular questions. Technically you do, you just got to rearrange it in a slightly different way. But if I pull up the formula sheet and you're just sort of looking, you know, left to right between what you have on your sheet and what's on the question, none of these seem to line up. You got xn, you got e of x. 1 on x looks pretty close, but it's not quite right because you need it over here, kind of. What it turns out to be the case is any of these kinds of things can be rewritten with negative indexes. So 1 divided by x minus 3 could be instead written as x minus 3 to the power of negative 1. So if we go ahead and do exactly that, it'll now become a bit clearer how we handle that situation. So let's cross this off. We had x minus 3 power of negative 1. Now when we look at our formula sheet of derivatives, this is now appropriate for that first dot point. It is something to the power of something else, some x to the power of n, where n in this case is negative 1. This is also a chain rule, and the reason why is because it's not just x to the power of negative 1, it's a function to the power of negative 1. So in order to do these kinds of questions, you do also have to be familiar with chain rule, which is probably why those are a bit tough. Answer sheet from the school was hard to understand, makes it confusing. Yeah, especially for first principle stuff. Like, I don't know how deep they do the working out for first principles, but like those get a bit long. Like for this one in particular, they do want you to do it by first principles, but before we get into that whole list of working out, we'll do it. Actually, have you done chain rule yet here? Do they show a summary? I guess I'll just ask, have you done chain rule? Do you know what I mean by chain rule? Okay, like as a recap, basically the way chain rule is going to work. The chapter doesn't teach it. Okay. Do they have any other questions that actually requires the chain rule? Let's see. So this one by first principles technically you could do. This doesn't need it. Yeah, okay, none of these actually explicitly need it, especially if you're doing it by first principles. So maybe this was a bad example. We'll start with these ones here, just so you can get an idea of what's going on. So rewriting our fractions as negative indices allows us to still make use of that first dot point. x to the power of n doesn't necessarily mean positive n. That integer could also be a negative one as well. So if we're using our formula sheet to solve that particular question, if I pull up this one, 3x power of negative 2, 5x power of negative 1, and 6, it is still just power down the front, reduce it by 1, just like you've done before. So the n, whatever the power is, goes down at the front as a coefficient, and that n gets reduced by 1 further. So this will mean negative 2 comes out the front here, making this negative 6, and the negative 2 now goes down to negative 3. That's the other weirder thing about it, because you're subtracting from negatives. It feels like the number's getting bigger, but in reality there's a negative in front of it, so it is in fact still getting reduced by 1. Power goes down the front, so because it was positive 5, it's now going to be negative 5, x power of negative 2, and any constant obviously just disappears. So this is the basics of what's going on. You're essentially converting something like 3 over x squared to now look like this, 5 over x to now look like that, so on and so forth, and then using your table of derivatives to help you out. If you have bigger fractions like in 4a, you're just distributing that divide by z squared across everything. So the 3 would cancel, the 3 would be left alone, this would now be 2z minus 1, this will be 4z to the power of minus 2. Is that concept clear enough, at least as far as the quicker derivatives approach? Okay, feel free to cut me off, but we'll now go on to the first principles question here then. So long as that's okay so far, when it comes to doing this by first principles, we're still going to do the same idea, which is 1 divided by x minus 3 is now going to be flipped to x minus 3 power of negative 1. That's our f of x. Now, to do differentiation by first principles, what it means is we want to do the following. If I pull up the equation for it, you want f of x plus delta x, or the book will typically use h, minus f over h, or delta x, and you're doing the limit as that approaches 0. What you'll typically find is that they'll say limit h approaches 0 of f x plus h minus fx over h. That's pretty much where you'll start in all of these. Now, it doesn't give you any specific starting point. It doesn't say like find gradient at x equals 3 or anything. It just says find f dash by first principles. What that means is we're not going to be subbing in an x value, we're doing it purely algebraically. So this statement here, f of x plus h, just means replace every instance of x with x plus h. So when we go ahead and write up our new numerator, we're still going to have our limit as h approaches 0. We're now going to have x plus h minus 3 power of negative 1 minus f of x. So f of x hasn't changed. X minus 3 power of negative 1. Then from there, dividing by h. These are pretty nasty, because in order to solve these more properly, expanding that out doesn't seem overly reasonable. And so one of the things I would suggest here would be to split the fraction up. So because you've got a plus or minus separating the terms, you can now do these in separate fractions. You've got x plus h minus 3 power of negative 1 over h minus x take 3 power of negative 1 over h. Now, because these have negative indexes, those will flip to the denominator. So if you can see that right away, awesome. If not, one thing to consider is that pretty much anything in the numerator can be thought of as multiplying 1 divided by the denominator. So in other words, I could rewrite this as saying x plus h, whoops, that's got to have a minus 3 in it still, x plus h minus 3 negative 1 multiplying 1 over h. And now when you flip this into what it should be, 1 over x plus, correct order would be good, x plus h minus 3, multiplied by 1 over h, it's now a bit clearer why that's going to distribute straight through the denominator. So in total, it's going to end up with 1 over xh plus h squared minus 3h, and you're starting to see why the working out for this is going to be pretty nasty. Before I do the same thing to the other one, is it clear enough, that sequence of why these will end up being distributed through the denominator? Cool, okay. So I'll just finish this one off then. So we'll have minus x take 3 is going to go down to the bottom, so you're now going to have xh minus 3h. Now, subtracting those two terms cannot be done because the denominators are not the same. So we have to get them to be the same. The way we do that is with a cross multiplication. Alright, multiply top and bottom by this denominator, multiply top and bottom by this denominator. This is where the math starts to explode out a little bit. So we're going to have xh minus 3h on top of this, minus all of, because remember it's minusing the full fraction, minus all of xh plus h squared minus 3h. And then on the bottom is now the product of those two terms. xh plus h squared minus 3h multiplied by xh take 3h. From here, you just need to expand out that denominator. Actually, should you? Can you factorize the numerator instead? Because we want to have this all cancel down to have... What do we need to have happen? Its limit as h approaches 0. Can we just shove in h equals 0? We cannot right now. But if we expand that out, it's still going to have a bunch of h's in there. Where should we stop? Let's simplify the numerator first before we do anything to the denominator. I feel like there might be a factorizing sort of cancellation that could occur. xh minus xh, those are going to disappear. Minus 3h minus 3h, those are going to disappear. So what you're left with on top, yeah, okay, we're going to have to. Something about this seems off now, because you're going to have negative h squared on top. And that's just going to force the whole thing to 0. That's strange. If you cancel out, well, yeah, I guess if you expand this all out, there should be a h squared in everything, and that will cancel out top and bottom, leaving a negative 1 on top. Yeah, and we should expect that too, because power negative 1 means the overall coefficient should be negative. Yeah, okay, so expanding out seems like the right idea. So xh and xh is going to get us x squared, h squared. Xh and minus 3h is going to get us minus 3x h squared. Yep, h squared and xh is going to get us xh cubed. H squared and minus 3h minus 3h cubed. Where was I? I just did h squared minus 3h, yep. Minus 3h xh for minus 3xh squared. Minus 3h for positive 9h squared. Yeah, okay. There's a h squared in everything, so that will now cancel down along with most of these, leaving you with -1 on x squared minus 3x plus xh minus 3h minus 3x. From there, these will combine up, and our limit as h approaches 0 will kill that, giving you -1 on x squared minus 6x. Yeah, and the h approaches 0 will kill those. There's a lot of algebra there. I might have made a small mistake at some point in there, but that's at the very least the gist of what you'd be doing. Let me pull up the 17C. Well, I guess I can actually just diff it on the CAS and see if that's what we get. Seems about right, because you're going to have a square on x minus 3. Let's see. Diff of 1 on x take 3. And if that gets expanded out, x take 3 all squared. The +9 should be in there. Oh, it's because I didn't scroll far enough to see the +9 that should still be there. So that didn't fully die, only the h squared died. That's my fault for not scrolling far enough. There should be a +9. So yeah, that's how you end up doing that. If you get a question like that in your SAC, you'll almost be thankful, because they should give you a lot of marks to do all that algebra. Because if we just look at the sheer number of lines of working, you're going to want to convert to the negative index. You could potentially go straight to here, so line 2. Line 3, you want to split it up, definitely. You probably don't need to go to this extreme to show things, so maybe your line 4 ends up looking like this. Line 5, line 6, line 7, line 8, so lots of working there. That's the whole procedure end to end. Is there any questions about any part of that? Definitely something that just needs a lot of practice, because it's a lot of algebra. And unique in the way that usually when we're doing diff by first principles, we're doing it purely in the numerator and then cancelling out a h. In this case, we're doing almost exclusively in the denominator, actually, by the end. And then making sure that the h's that get cancelled out don't fully invalidate the function. Any questions at all? Definitely don't envy when this was required in the study design. Unit 1, 2. So by the time you get to Unit 3, 4, you just basically don't do diff by first principles anymore. But okay, that's the diff by first principles thing. The rest of those are significantly easier when you're just using the answer sheet. Well, it can't put really any like verbalization behind it. I'm sure the answer sheet probably looked more or less like this, but because it wasn't explained step by step, it just looks significantly worse. Maybe another thing to add, I know I got lazy with it, kind of just want to make sure that you still put the limit as h approaches 0 in part of your working out all the way through until the very end, because that's the correct like actual working out for it, but for the purposes of just showing the algebra, or speeding things along a little bit. Would you lose marks for it? Now, that is a great question. For the SAC, you'd have to ask your teacher. For the exam, well, I guess for the exam it's not even part of it. So I don't really have anything to base this off of. Unit 1 and 2 is fully regulated by schools, so that's a question to ask your teacher. I would check the exam reports, but it doesn't show up in Unit 3, 4. So I'm inclined to say no, it won't make you lose marks, because there was that whole thing where I used to think if you had y equals f of x, you should do dy dx, whereas if you had just f of x, you'd have to do f dash to show your derivative. And that was not the case at all. They didn't care about what notation you used so long as it was clear enough. And so I feel like as long as you put the limit in there at least at the beginning, you're probably fine, but ask your teacher. It'll be fully regulated by your teacher. Those will be the main questions there. Is there anything else that's crazy in this? Find gradient of secant, hence find gradient of tangent line. These are just the same thing, but they're giving you, like you'll notice it's 1 f of 1, 1 plus h, f of 1 plus h. It's still just saying do diff by first principles. So the exact same working out you did for what we just did here would be what you do for this, only instead of doing x plus h, you're doing 1 plus h. So at least it's numerical. You can actually expand things out a bit easier. And then literally whatever comes out of that just becomes the gradient. Because that's the whole thing of doing derivative by first principles. What comes out of it is either the derivative, if you did it purely in terms of x, or the gradient, if you did it with an actual number to start with. This shouldn't need the cas. And then some of these, since you haven't done chain rule, yeah, or even product rule for that matter, yeah, you'd probably need cas for that. Find x bar. Yeah, and then some of these are just basic derivative questions that you just solve cas. So that should be fine. If you have any trouble with any of that, feel free to either message me or even send it as a question to be covered in a live class. Was there anything else in that chapter section that should be looked at? All good. If not, feel free to let me know. Otherwise, we'll just move on to part B here and round out the rest of the class. Cool. So as a reminder, we were doing continuous probability here, and basically we have machine A given by the continuous probability function. We found the value of k already. That'll still be in our cas, so no need to find that again. Part B, find the mean time. We've actually kind of already done this for continuous. We entered it in the previous question. It's just x f of x, so let's just go ahead and ignore that one. Part C, in a sample of 80 widgets, how many would be expected to have taken? Okay, well maybe we do need to do part B. In a sample of it, oh actually, maybe not. Yeah, I don't think we might not need part B for this. We have a sample of 80 widgets. From this continuous probability distribution, how many would be expected to have taken more than 10 seconds to produce? It's a bit of a two-parter question.
Do we calculate the percentage from binomial and then times it by 80?
Yeah, that's exactly what we do. So for more than 10 seconds, that's going to be from 10 to 12. Remember, this is continuous. We don't need to like round up to 11, for instance. So exactly as before, 10 to 12. Whoops. 10 to 12 of function. You can go ahead and just immediately multiply it through by the 80 widgets. And that'll get you a nice clean number actually of 25. Yeah, how many would be expected? 25. So I guess you just answer 25 widgets. What is the probability that a widget takes more than 11 seconds to produce, given that it took at least 10 seconds to produce? Very common wording. What's that reminding us of?
Conditional.
Conditional probability. Perfect. So, conditional probability formula. Let's make sure we get it the right way around. So, what's going to go on the left-hand side and what's going to go on the right-hand side of the conditional probability statement?
Given that, so the right-hand side would be at least 10 seconds.
Yep.
So x is equal to or greater than 10.
At least, yes, so that will be 10 or more, yes.
Yep. And then on the left-hand side, sorry, it would be So just 12 seconds.
More than 11 seconds. We don't. So it's continuous. We're not going to round that way. So more than 11 still would just be
Okay.
x greater than or equal to 11. Or I guess if you really wanted to, you just say x greater than 11, even though it won't actually change the calculation. Yeah, because 11 and 12, perfect. Cool. Then our numerator is just the intersection of those two things, and the denominator is going to get the conditional x greater than or equal to 10. Only challenging part about this will be figuring out how this intersection works. This one might not be too bad to figure out what that condenses down to. Otherwise you could use a number line if you really wanted to. Does anyone know off rip what the intersection of these two will condense down into?
11 and 12.
Yeah, 11 to 12, exactly. Greater than or equal to 10 and also greater than 11, they're all pointing in the same direction. So that's just going to be 11 to 12. This way. Perfect. And then this one's just, well, I guess 10 to 12. 10 less than x less than 12. That's just two continuous probabilities, so two integrals of the exact same thing and then just dividing it through. In the interest of time, we'll probably just skip the calculation unless people are really keen to see what that looks like. It'll just be integral 11 to 12, integral 10 to 12, and divide the two. Next up, the time taken, y seconds, to produce a widget using machine B is normally distributed. Find the probability that a randomly selected widget from machine B has taken between 8.5 and 10.5 seconds to produce. Fairly trivial one, I would imagine. That one's just going to be a basic normal CDF. So we got the mean, we got the standard deviation, and we got two x values that we want to do it between. Normal CDF. It's talking about machine B. Machine A stuff is still relevant if it comes up. Next up, if the probability of y greater than A is equal to 5%, find A correct to 1 decimal place. Haven't done this one before. Does anyone remember how we might do it?
It's the integral of the function. Make A the lower bound.
Yep.
So for A as it equals 0.05.
Pretty good. What function?
Was not fx with the change k. Oh no. The standard deviation function.
Yeah. So you could absolutely chuck the normal distribution equation and do it via integrals. We saw a bit earlier, I don't know if you were there for that one, that the CAS kind of shits itself a little bit and takes a while to calculate and process that. There is a CAS inbuilt function that speeds things along, and that is doing the inverse normal. It'll do exactly what you just described, but it'll save you the calculation time, and it'll save you actually having to input that entire big nasty normal distribution equation. Only thing, at least with this, with RTI Inspire here, is that we have to make sure the probability is pointing left. This one is pointing right, because it's greater than A, everything right of A. So we want to have to flip that area to 0.95 instead. 0.95, mean of 10, standard deviation 1.2. That's going to get us 11.97. Is that going to make sense? Yeah, seems about right. It's going to be right at the mean. We would expect that since it's 5% pointing right. And if the standard deviation is 1.2 seconds, it's a little bit more than one standard deviation over. That about checks out. Cool. Just because we're about to hit time, I might briefly just touch on what you would do for these. So let's see. A widget which takes more than 12.2 seconds is considered unprofitable. Random sample, so already sampling and estimation. Machine B, so we're using normal distribution to calculate it. At least one is unprofitable, so more than 12.2, you're just doing a CDF from 12.2 to infinity. And at least one, so it's now using the binomial stuff. Remember, binomial and sampling and estimation have basically the same sort of approach to it. You're just flipping between one and the other depending on if it's proportional versus if it's integer related. This one has the integers themselves, so we're using, well, we're always going to convert it back to integers anyway, because we need to use binomial for it. And this one will just be a binomial CDF of 1 to 60, yeah, 1 to 64, using the probability from the normal distribution of a unprofitable widget. Any questions as to how that one will work? Happy to do that one live just to finish it off if we need to see the working out for that.
For on my CAS, I defined the value for k.
Yeah.
I defined the value for k, and then defined the h of x, and then I put in the same integral, but then it's saying error argument must be a variable name.
At what point did you get the error? Sorry.
Just after I put it to calculate the integral.
So, like exactly this one that's highlighted here.
Yeah.
Okay. When you put the multiplication of 80, did you do it outside the dx or inside the dx?
No, it was. I was trying to do it how you did it, but it comes as d bracket x times 80.
Yeah, it's because you it's because see how the cursor changes when you're inside the x spot.
Oh,
You did the multiplication inside that. You just got a toggle out of it. Yeah, I was kind of hesitating.
What was wrong with the variable?
Yeah, I was hesitating whether or not I should do that. I probably should have just did this so you can see the probability and then just multiply it by 80. Obviously that broke because I...
Yeah.
Actually, no, that's... What did I do there? How did I get 800 in there? Anyway, whatever. Yeah, that would have been probably a better way to go about it. But yeah, that also happens with... What... I feel like I've had that happen before as well. There's little few nuances of the CAS to watch out for. The main ones are going to be, by far, making sure you put multiplication symbols between things. For whatever reason, like if you go to graph or if you go to try and use that function again, sometimes it gets a bit crazy if you don't genuinely put multiplications between each thing. Can be hit or miss, so you'd rather guarantee things than try to play catch up with errors. Anyway, that's about it. I'll leave you guys to enjoy the rest of your day. If anyone still wants to stick around for me to do I, or ask me any other questions, feel free to do so. I'll be around. Thanks so much. No worries.
Thanks. See you.
All
Have a
good.
good week.
Yeah, you too. Take care.
Hello, I've got a question about this question I'm doing right now.
Yeah, yeah,
Can I take a screenshot and I'll send it in the chat?
yeah, for sure.
Yeah. I sent it. Should be there.
It's just buffering right now.
Yeah.
Got it. Continuous across. Okay, let me can I set my screen share to a thing called chat images? I cannot. Okay, let me just download this. PNG, open the PNG. Set the screen share. Hopefully that's readable for...
Yeah.
Yep, cool. Okay, so what are we looking at? It's a continuous probability thing with a actual genuine piecewise. Find expected value. Was it A or B that you like? Did you need help with both or just one of them?
Just A, because for some reason my CAS is, I don't know why, it's not defining it properly, or I don't know how I'm supposed to define it to make it.
Yeah, because for this, I wonder if it will bug out a little bit trying to do x times f of x if it's a piecewise.
Yeah, it gave me undefined.
Did you put an undefined? Okay. Well, like the way to do this, if that's not working, doing just basic integral x times f of x over 0 to 2, you would just do it in parts. So for expected value of x, yeah, you would do it in parts and add them together.
But how would I do that? So if I had like, for example, the first part, f of x was x,
Yep.
would it be 0 to what? Because it wouldn't be 1, would it?
It would be, so it ends up being x times x for x squared, and you're doing that from 0 to 1. That gives you your first result.
Wait, sorry, say that again.
Then adding that to the second result, so that will be 2x minus x squared from 1 to 2.
Would it be divided by 2 because it's two different functions, or no?
No, because when it comes to integrals, remember over like the way you can handle integrals is either do it all in one go or split it up into separate domains and add them.
Yeah, okay.
So that's why it's additive rather than needing to like average it out, for instance.
Okay, okay. Thank you.
Yeah, that should be how that one goes. And part B was all fine. That cased out.
Yeah, that's all right. Yeah.
Yeah, sick, awesome.
Thank you.
No worries.
Thanks, Chris.
Yeah, no worries.